Hi. Once again, we're starting off with some review problems. So if you have that sheet of paper, that notebook, where you've been keeping track of review problems, that would be great to get that out. I put a couple of matrices up here on the board. Matrix A, Matrix B. Take a minute, get those copied down. We're going to do a couple of things with them. So first, we're going to find the determinant of A. Now remember, that's when you see these vertical bars, you're finding the determinant of the matrix. So, do you remember how to do that? To find the determinant, we take the first two columns, and we write them down over here. The first two columns, these are columns. We write them down over here. And then remember, we start right here. Are you looking where I'm starting? We start right here. And we multiply those numbers together. So that's going to give us a -2. And then we multiply these together. Ooh, that's a big one. That's 60. And then we multiply these together, and that is 0. Now, I am going to add those three numbers up. So I'm going to add the -2, the 60, and the 0. And I'm going to get 58. Now, I'm going to do the same thing this way. So I'm going to multiply these together, and that gives me 15. I'm going to multiply these together, that gives me -24. And these, again, I get 0. Now I'm going to add those up. So I'm adding up the 15, the -24, and the 0. And that gives me a -9. Now the answer to the problem is going to be taking the first number I got, which is 58, minus the second number I got, which is -9. So 58 minus -9 is going to turn into 67, and that is the answer to the question. Okay? Now, we're going to use the same two matrices that I have up here. We're going to do another problem, another review problem. Okay, so here we go. Now we're going to find A plus 2B. So using those two matrices, we're going to find A plus 2B. All right, so we're going to take matrix A, and we're going to add 2B. Now, remember, 2B means we just distribute a 2 times everything in B. So that would be 10, -2, -8. I'm just taking 2 times all these numbers. So 16, 6, 12, and 2, -2, -2. So here's matrix A. And now I've taken 2 times everything in B. And now I'm going to add them together. So I'm out of room on my little board here, so I'm going to go ahead and just write the answer up here. Remember the rule for addition. If we're going to add them, they have to be the same size. And these are both the same size. So I can go ahead and add them. And I do that entry by entry. So 1 plus 10, 2 plus -2, 3 plus -8, 0 plus 16, 1 plus 6, 6 plus 12, 5 and 2, -4 and -2, and -2 and -2. Now, hopefully I added right. I'm adding those entry by entry. So for example, to get this number, I added this and this. The entries that are in the same spot in the matrix, I add those together. So I think that looks okay. And there you go. Now we have added those matrices. Two things to remember about that. In order to add or subtract, remember you have to have the same size matrices. So these are both 3 by 3s, 3 rows, 3 columns, so that I can add. And second, this 2 right here in matrix land is called a scalar. So that's one of our vocabulary words that you are required to know. That guy is called a scalar. He is just a real number functioning as a coefficient that we distribute through matrix B. Okay. All right, one more review problem, and then we'll be ready to move on to some more linear programming. One more review. Like you get your calculators out, please. We're going to do a quick little calculator review. All right. So we have this nice little system of equations, and we are going to use our calculator to solve this system. So remember, what that means is we're going to put a matrix into our calculator. Then we're going to use that very special RREF button, and a matrix is going to come out of the calculator. And the matrix that comes out should provide us with our answer, the X, Y, and Z values. So that's all there is to it. Do you remember how to do it? So what matrix goes in? You do have to write this down, so please write down the matrix that goes in, which is just the numbers. So it'll be 1, 2, -1, 2. 1, 2, -1, 2. Then 3, 1, 5, 20, and 2, 5, -3, 3. Remember, at any time during the review or during the regular video, you can always stop me, rewind me, so that you're able to keep up. All right, so I have made a matrix now that is full of the numbers from the problem. I've been very careful, I hope, to include any negatives that might be in there. Okay, so now I'm going to get my calculator out. So I have my calculator out, and I'm going to turn it on, and I'm going to go to matrix, right here. Oh, wait, I forgot to press second. Sorry about that. Let's go to matrix, second matrix. So second matrix. I want to put these numbers in, so I'm going to click across to edit. And it wants to know, how big is the matrix you're putting in? Well, how big is the matrix I'm putting in? It has 3 rows and 4 columns. So I am putting in a matrix that has 3 rows and 4 columns. Now, the last one we did, on my calculator anyways, was that way. But I'm going to go ahead and put in 3, enter, 4, enter again. Now, I've used my calculator for many problems, so there's still numbers in there. Do not worry about that. Simply type in your new numbers right on top. So I'm going to type 1, enter, 2, enter, -1, and I'm really careful to use my negative button here, not the minus sign, and 2. Now my top row's in, So I'm going to do the same thing for the next row. 3, 1, 5, 20, and 2, 5, negative 3, 3. It's very simple, guys. Just type in the number and hit enter. Now, once you have the last one in and you've pressed enter, then remember we second quit, and then we go back into your matrix menu. But this time, instead of going all the way over to edit, we only go over to math, because now we're ready to do something. So I press math, then I'm going to go all the way down to RREF, press enter. Then I need to tell it, the calculator says, oh, you want to RREF. What do you want me to RREF? Well, I want it to RREF matrix A. So I'll go back into my matrix menu, second matrix, and there's A right there highlighted. And then I'll press enter. And the answer comes out, the matrix that comes out, which I'm going to write down, looks just like this. Now, gang, if yours doesn't look this way, then you need to go back and make sure that you are putting in these numbers exactly. It's very, very easy to get distracted, to go too fast or whatever. Go back, type in the numbers again, because there is no way that your calculator will say anything else. If you type in these numbers correctly, this is what should come out. Now, do you remember what this means? Remember, when you put these numbers into the matrix, this was the X column, the Y column, and the Z column. Those were the numbers that you put in. 1, 3, 2. Those are the X's. So here are the X's. Well, what does this say? X equals 1, Y equals 2, Z equals 3. And that is the solution to the system. Okay, good job. Now, I need you to get your notes out. And we are ready to pick up with linear programming problem number 3, which is actually on the page that's labeled 48 up here at the top. But it's linear programming problem number 3. So while you're finding that, getting that out, getting that organized, I'm going to go ahead and put my chart, my table, up here. Okay, and the table's all set up. It says cutting, sewing, profit, knit, worsted, total, and hopefully while you are while I'm doing this, you're kind of reading through the problem and maybe trying to come up with your filling in some of the numbers in the chart. All right, so here we go. Let's see what it says. It takes a tailoring firm 2 hours of cutting and 4 hours of sewing to make a knit suit. So here's knit. Takes 2 cutting and 4 sewing. To make a worsted suit, it takes 4 hours of cutting and 2 hours of sewing. At most, 20 hours per day are available for cutting, so the total cutting is 20, and 16 total for sewing. The profit on a knit suit is $34, and on a worsted suit is $31. How many kind of each suit should be made to maximize the profit, and what is the maximum profit? Okay, so obviously when we read the last sentence, what we want to maximize is our profit. And we just need to figure out how we're going to find our profit. Okay. So I don't have any variables. What are we going to let our variables be? What do you want X and Y to be? I think your question will answer it. How many of each kind of suit? So we're going to let X be the number of knit suits. And we're going to let Y be the number of worsted suits. Well, then it's pretty easy to figure out what our profit will be. I make $34 on every X and $31 on every Y. So won't that just be 34X plus 31Y? That is my profit statement. Now, what are my restrictions over here? They call them constraints. What are the things that are kind of limiting me in the problem? Well, I only have 20 hours of cutting available. So 2 X's and 4 Y's have to add up to be less than or equal to 20. I don't have more than 20 hours. So for cutting, 2 X's plus 4 Y's has to be less than or equal to 20. And similarly, 4X plus 2Y has to be less than or equal to 16. Those are my constraints. Those are the things that are limiting me. Now, you remember from yesterday that there are a couple of gimmies that we can always put in. Do you remember what those are? What do we always know about X and Y? We always know that X and Y are positive. Greater than or equal to 0. And again, that is set up in your graph on your paper. Notice that we only have quadrant 1 drawn on our paper. You do not have to worry about graphing these. When your grid is set up as it is, when your grid is set up as it is, here are the axes. You're in quadrant 1. This is quadrant 1. 2's over here. 4's down here. Only quadrant 1 is shown. So you don't have to worry about graphing those. They're already taken care of for you. You just have to worry about graphing these. So I find colored pencils or markers or something helpful. You don't have to do it if you don't want to. But I'm going to use purple today to graph this one. I'm going to graph this one in purple. So you remember last time we talked about the easiest way to do this is to graph using the intercepts. So I am going to let, one at a time, my variables be 0. If I let X be 0, then Y is 5. I want you to look at this top equation, kids. If I let X be 0, if this goes away, then clearly Y has to be 5. So I'm going to plot the point 1, 2, 3, 4, 0, 5 right here. So I have plotted the point and I have labeled it. You are doing the same on your paper. Now, I'm going to let Y be 0. I'm going to cover up this Y. So X must be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I am plotting the point 10, 0. So I've plotted the point 0, 5, and I've plotted the point 10, 0. Now, do you remember what you do? Connect them with a nice straight line, as straight a line as you can. Connect them. That's going to form this little triangle. And you're going to shade. And since that's a less than, we're going to shade underneath. Now we're going to repeat the process. I'm going to use my green marker. And I'm going to graph that equation. So again, I'm going to cover up x. Y is 8. Right here, y is 8. Then I'll cover up y, and x is 4. Now I'll connect those two dots, the green ones. And again, because it is a less than equation, I'm going to shade underneath. And if I shade underneath the green one, I've already shaded underneath the purple one. Can you see that I'm going to get this little shape right here? And that little shape that is a combination of the purple shading and the green shading, that little shape has 4 corners. Those 4 corners are called vertices. Next thing you do is write down those 4 corners. Some of them are super simple to write down. For example, this one right here is the origin. This one is the point 4, 0 because I plotted it. This one is the point 0, 5. So those are the easies. 0, 0, 0, 5, and 4, 0. The one that's a little bit trickier is this one, because he is not a plotted point. I mean, I didn't plot him. He happened when the green line and the purple line intersected each other. So if you have a perfect graph, go right ahead and guess what that point is. I don't like to do that, so I'm going to go ahead and write down my purple and my green line, and I'm going to do substitution or elimination to figure out where those 2 lines cross, because that is exactly what I'm trying to do. I'm trying to figure out where the green line and the purple line cross. And I will do that by taking the 2 equations, the purple line and the green line, and using substitution or elimination to find the point where they cross. So I think I'll use elimination. You know me, I love elimination. So I'll multiply the top one by -2. So I have -4x minus 8y equals -40. I'm multiplying my top equation, -4x minus 8y, -40. And remember, I know we talked about this yesterday a lot. I know these are inequalities, but the only thing you use the inequality for is shading. Everything else, treat them like equations. Treat them as an equation for everything else. All right, so I've multiplied the top one by -2. I'm going to add it to the bottom one. And I'm going to end up with a -6y equal to a -24. Does that look right? Which means my y coordinate is 4. Now I'm going to go back to my equation. You can use any of these. So I'll go to this one right here since I haven't messed it up. So 4x plus, now y is 4, so that's going to be 8. equals 16. So 4x equals 8 and x equals 2. So I don't know if you could tell. On mine, it kind of looks like that is the point 2 comma 4. Now I have all of my points. So do you remember what you do next? What is the very last thing that we do in terms of solving the equation? Oops, wrong way. It's the very last thing we have to do. Now we have to take each of these x and y values and plug them into our profit equation. Okay, so obviously if we put in 0, 0, we get 0. If you don't make any suits, you're not going to make any money. What if you make no x's, but you make 5 y's? Well, let's take 31 times 5. So we would make $155. What if we made 4 x's and no y's? Let's take 34 times 4. You make $136. All I'm doing, kids, is plugging in the x and the y value right into my profit expression. So now I'm going to put 2 in here and 4 in here. And I got $192. So let's not forget what the question was. The question was, how many of each suit should be made to maximize profit, and what is the maximum profit? So we'll write a sentence that says, they should make two knit suits and 4 worsted suits for a profit of $192. Now again, don't you dare whine and complain about having to write a sentence expressing your answer. Good grief, look at how much time and energy that problem took. So the least we can do is write a nice, neat answer. Okay. All right. Well, we got another one. Here we go. Let's move on to number 4. So while I am getting it set up, why don't you read through number 4, which is the problem that says we're producing skateboards, different kinds of skateboards. Okay, so I do want to point out, boy, my memory's not so good, but I think every problem that we've done so far, like this, has asked us to maximize, which is great. And obviously if we're talking about profit, that's what we want to do. We want to maximize it. But these same kinds of problems can be done to find minimums too. So you might want to, if you're a businessman or woman, you might want to minimize your expenses. Or you might want to minimize the amount of raw materials you need. So it is possible to do these problems in a minimized fashion also. Obviously, if we're doing them to find a minimum, when we set up our ordered pairs and we find all those values, we don't pick the biggest one, we pick the smallest one. Okay, so now we're ready to go. So have you filled in some of this, I hope? The total number of hours per day available for production is 85. So the total production hours is 85. This was production. I kind of abbreviated. You have the chart in front of you. There are 40 hours for finishing. Pro boards require 1.5 hours of production time. So pro boards are 1.5 production and 2 hours of finishing. Specialty boards require 1 hour of production and a half an hour of finishing. Profit on a pro board is 50. Profit on a specialty board is 65. And we want to maximize the profit and find the maximum profit. Okay. All right, so here we go. Do you have some stuff filled in your chart like this? How about your constraints? Have you been able to write any of your constraints over there? Do want to remind you that you need to set up your variables. You got to have an X and a Y. So what are we going to let X and Y be? Doesn't it make sense to let X be the number of pro boards and let Y be the number of specialty boards? Doesn't that just make sense? Again, the question at the end gives you the clue. How many of each type should be made? That's what you're trying to figure out. That's your X and your Y. Okay, so here's our X, here's our Y. All right, what do your equations look like? Right here. Right here's one. 2x plus 1/2 y, and you can write that with a fraction or a decimal, it doesn't matter, is less than or equal to 40. So when you are finishing, whether it's a pro board or a specialty board, you only have a total of 40 hours to do that. 1.5x plus y is less than or equal to 85. That's your production time. All right. So we're ready to go. Oh, wait. What else do we know? We know X and Y are both bigger than or equal to 0. And we know that our profit will be calculated by taking 50 times X and 65 times Y. All right, so you know what we do now? Yeah, now we're going to graph. Now, this problem involves big, big numbers. So you do whatever you want, but I would recommend that we change the scale. So, for example, here's what I mean. If I cover up the Y, X is going to be 20. So I might want to change my scale. So instead of having each block be 1, each block might be 10. You're allowed to change your scale any way you want, but I think that's what I'm going to use because I see I'm going to have a big number like 85 coming in too. So I'm going to do this equation in purple, and I'm going to use a scale of 10. Okay? So when I cover up x, or excuse me, y, when I cover up y, x is 20. I'm covering up y, x is 20. There went Lucy again, by the way. Okay. So there, I plotted that point, 20, 0. Now, don't panic. If you cover up x, then it says 0.5y equals 40. So how will you figure out what y is? Well, you'll either know intuitively or you'll divide 40 divided by 0.5, right? So that's 80. You got a calculator, type it in. 40 divided by 0.5 will be 80. So I'm going to plot the point 0, 80. And then I'm going to connect those with a nice little line. So far, this is what I've got. Sorry about that glare. Okay? Now again, I don't want anybody freaking out. If I let x be 0, it says 0.5y equals 40. Divide both sides by 0.5. That's how you get 80. Okay? Now, I'm shading underneath that. So I just have my skinny little triangle there shaded in. All right, now I'm going to do this one. So if I let x be 0, y is 85. So y is 85. My markers are so big and fat. But that would be the point right above my 80. It's right above my 80 there at 85. So the 81 is right on the line. The 85 one is halfway between the 80 line and the 90 line. If I let y be 0, then I have the equation 1.5x equals 85. If I let y be 0, so I have to divide by 1.5, which I can do on my calculator. And it's about 56.6 or 56.7. So I'll plot that point. 1, 2, 3, 4, 5. Okay. So remember, I let y be 0, so I was finding my x. On the calculator, it came out to be 56.7, which is clear out here. So now I'm going to connect those two dots. Now, every time you do one of these problems, kids, you do not know what's going to happen. This is a little bit strange because notice that the green line is totally above the purple line. The green line is totally above the purple line. So when I do my shading, the overlap is just going to be the purple part. Right? So my corner pieces are just the corners of the purple because that's the overlapped part. The purple triangle is the overlapped part. So instead of having 4 points this time, I only have 3. What are those points? Well, they're real easy. I don't even have to find them. They're real easy. I have 0, 0. I have 0, 80. And I have 20, 0. that's it. Those are the corners of my purple triangle. And again, I don't worry about overlap. I mean, I do worry about overlap, but it's not anything different than the purple triangle because the green triangle is outside of the purple triangle. So when I overlap them, all I get is the little purple triangle. So now I'm going to calculate my profit. Obviously, if I don't make any skateboards, I don't make any money. If I make none of these but 80 of the Y's, I'd make $5,200. And if I make 20 of the X's, I'll make $1,000. So, I can answer my question. Obviously, erase all this. What should I do? I should make $80 specialty boards. And no pro boards for a profit of $5,200. Now guys, I know that problem's a little bit different, but you better get used to that because out there in the business world, everything comes out a little bit different. It's not always going to be exactly the same situation. The steps you go through are exactly the same. So we'll go through exactly the same steps each time, but we won't necessarily get exactly the same kind of answer. That completes our note packet. So now what I would like for you to do is find those of you who were in class got a couple of other things. Those of you that weren't, they're available in the Schoology. You can print them off or put them in Notability or whatever you want. But I am looking at the one called Linear Programming Worksheet. A paper called Linear Programming Worksheet, and it looks like this. Linear Programming Worksheet. Mine is stapled to something, so the first page looks like this. So if you got a stapled packet, that's probably where yours is too. But if you never got a packet, which some of you didn't, then find the sheet called Linear Programming Worksheet. All right, now while you're looking, just pause the video. It would be very helpful for you to have the sheet in front of you so you can pause and go find it. I'm going to go ahead now and do this problem. So again, you can either write down everything I'm writing down, or you can find your sheet and come back when you do. All right, so this time we're taking a test that has questions A and B, or type A and B. We have the number of questions. We have an interval. I don't think we've had one of these before. That happens in quite a few of these problems. So we'll talk about that. You are about to take a test that contains questions of type A worth 4 points and questions of type B worth 7 points. You must do at least 5 questions of type A, but time restricts doing more than 10. All right, so I want you to focus right in, hopefully this thing's focusing, on that sentence. You must do at least 5 questions of type A, but time restricts you from doing more than 10. So that means that type A questions have to be between 5 and 10. So when we say a fixed interval, what we mean is those are the limits or the boundaries for that particular variable. Now I'm just letting x be A and y be B. I hope that's okay. So I'm going to do x questions of A and y questions of B, but whatever x is, it has to be in between 5 and 10. X is going to represent the number of question A's. Y is going to represent the number of question B's. And I already know that X has to be between 5 and 10. Now, what else do I know? I got to do at least 3 B's, but no more than 10. So Y has to be between 3 and 10. In total, you can do no more than 18 questions. So the total number of questions that you can do is 18. How many of each type should you do to maximize your score? Okay, so let's talk about all this so far. I have filled in everything that I can fill in. This time your chart's going to have 2 empty boxes. This box, even though I bled over into it, this is empty and that's empty. So let's talk about how I filled in all of those boxes. First of all, the number of A questions is X, and the number of B questions is Y. That is my variable. Altogether, I can only do 18 questions total. So whatever X and Y together are, it can't be more than 18. The problem very explicitly tells me that X has to be between, the number of A questions has to be between 5 and 10. And the number of Y questions has to be between 3 and 10. So those are constraints. Obviously, X and Y have to both be bigger than 0. These two are kind of irrelevant this time because you've already told me X is bigger than 5 and Y is bigger than 3. So you can list those if you want. Certainly, that would not be wrong, but you don't have to list them because they're kind of absorbed in this right here. So X and Y together have to be less than 18. And the limitations on X are between 5 and 10, and the limitations on Y are between 3 and 10. What am I trying to maximize? Well, I hope you're trying to maximize your score, right? You want to get as many points on this test as you can. So your score will be 4x plus 7y. That's what I want to get the most of. I want to maximize that score. Okay? Now, this is another time when, looks like I'm going to have an 18 in my problem. Feel free to either change your scale or simply to expand your grid to accommodate 18. That is completely up to you. I'm going to go ahead and use 18 because my graph will accommodate that. I mean, I'm going to go ahead and use 1 as my scale, but you can do whatever you want. All right, so I'm going to do this one right here in purple. So obviously, if I cover up one variable at a time, if I cover up y, x is 18. If I cover up x, y is 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, on each axis, I'm going to have an 18 marked. So I'll show you in a minute. So I've marked my 18s. I've connected them with a line. And because it's a less than, I'm going to shade inside. So I have this handy dandy triangle shaded from my top constraint, which I've labeled purple. Now I'm going to do this one in red. Well, maybe. That red marker's not very good. If you aren't sure how to do this, please pay close attention. It's very, very simple. Notice that this red thing right here deals only with x. There's no y in it. So I'm going to go to my x-axis, and I'm going to put a dot at 5. 1, 2, 3, 4, 5. Right there. There's 5. And then you guessed it, I'm going to put another dot at 10. 6, 7, 8, 9, 10. So I have a dot at 5, 0, and a dot at 10, 0 on the x-axis, because these are x's. That's just x. Then I'm going to draw lines, vertical lines, straight up, creating a bar here that represents all the points that have x values between 5 and 10. So all of your x's are in this area right here. This is where your points are now. So I'm going to shade in between those two lines. So as of right now, I'm looking at this area right here. That is the part that is red and purple. Okay, but we're not done, are we? Because now we have a green part. Now those are y's. This is simply y. There's no x's in there. It's just y's. So I'm going to go to my y-axis, and I'm going to put a point at 1, 2, 3. So this is 0, 3. And then I'm going to put a mark at 10, 4, 5, 6, 7, 8, 9, 10. 0, 10. And then guess what I'm going to do? Just like before, I drew up vertical lines. Now I'm going to draw horizontal lines straight across. And all the points that I need are in between those two bars. Now remember, we'd already been under the purple, between the red. Now we're between the green. So I'm going to outline the area that we are looking at. There it is. That is the area that we are looking at. So when you have your picture drawn, if you're using different colors, you're below the diagonal line, and then you are in between the vertical lines and in between the horizontal lines. So you should have a shape that looks similar to mine. There is a certain degree of accuracy that you do have to have in these graphs, so please be careful when you're doing it. Okay, well, look, now we don't have 4 points, now we have 5 points. We have this one, this one, this one, this one, and this one. Now, this one is very easy because we counted over 5 and up 3. So that is the point 5, 3. 5, 3. Over 5, up 3. So one of my points is 5, 3. Similarly, this one is super simple because it is over 10, up 3. One more super simple one right here. This one's over 5, up 10. So this is the point 5, 10. Now, these two aren't quite as easy, but they're sort of easy. Because let's look at this one right here. Are you looking where my marker is? Right here, that guy right there. We know that he's over 10 because he's on that red bar. So we know he's over 10. But he's also on the purple line, which is this equation right here. So if we know that his x, is 10, then we can figure out his y by plugging in 10 here. So if x is 10, the y has to be 8. If that confused you, we get to do it again, right here, this point. Now, what do I know about this point? Look, he's on this green bar. So that means that his y is 10. His y is 10. That point has a y of 10. Well, if his y is 10, then his x has to be 8. So again, those points, these points right here, are both on the purple line. If you're on the purple line, then your x plus y has to add up to 18. So as soon as we knew, for example, that the x was 10, because it's on that line, and all the x's are 10 on that line, then we just plugged that in, and that gave us a y value of 8. Okay, now either in your head or with your calculator, you're going to calculate the score for each of those points. Remember, this is how you get your score. 4 points for an x, 7 points for a y. So we're going to take each of these points and plug them in. So 4 times 5 and 7 times 3. So that's 41. Ten times 4 and 7 times 3. That's 61. 5 times 4 and 10 times 7. That's 90. 4 times 10 and 7 times 8. Is 96. And 4 times 8 and 10 times 7 is 102. So again, if you're not sure about what I'm doing here, these are your x's and y's. So for example, to find this one, I put 10 in here and 8 in here. So 4 times 10 plus 7 times 8, and that's how I got 96. And I have to do that for every single point. My whole job was to figure out how many questions I needed to do to get the maximum score. So I should do what? 8 question A's and 10 question B's. For a score of 102. And that is the answer to the question. All right, have a great day.